What if everything you know about life's origins is wrong? What if, instead of Earth being the birthplace of life, it all started on Mars? Could it be possible that we are, in fact, descendants of ancient Martian microbes? If this mind-blowing idea intrigues you, stick around as we dive deep into the science, evidence, and theories that suggest life may have begun on the red planet before making its way to Earth. Don't forget to like, subscribe, and hit the notification bell so you never miss out on more fascinating space mysteries. Do you think life on Earth could have originated from Mars? Or do you believe it developed independently here? Let us know your thoughts in the comments below. For centuries, humans have wondered about the possibility of extraterrestrial life. Among the many celestial bodies in our solar system, Mars has stood out as a prime candidate for supporting life. However, a fascinating and bold hypothesis suggests that not only might life have existed on Mars, but it may have actually begun there before traveling to Earth. This idea, often referred to as panspermia, proposes that microbial life may have originated on the red planet and subsequently found its way to our planet via meteorites. In this detailed exploration, we will examine the scientific basis for this hypothesis, the evidence supporting it, and the broader implications for our understanding of life in the universe. The conditions on early Mars. To understand the plausibility of life originating on Mars, we must first examine what the planet was like in its early history. Scientists believe that around 3.5 to 4 billion years ago, Mars had conditions that were far more hospitable than they are today. Evidence from NASA's rovers and orbiters suggests that Mars once had liquid water, a thicker atmosphere, and possibly even vast oceans. The Curiosity rover discovered clay minerals and other geochemical signatures that indicate the presence of water for extended periods, conditions that are essential for life as we know it. Additionally, ancient Martian meteorites have been found to contain organic molecules, which are the building blocks of life. The presence of these compounds does not necessarily prove that life existed on Mars, but it does indicate that the basic chemistry necessary for life was present. Martian meteorites and panspermia, a key aspect of the Mars to Earth life transfer. Theory is the presence of Martian meteorites on Earth. Over the years, scientists have discovered several meteorites that originated from Mars, such as ALH-8 4001, Nakla, and Shergodi. These meteorites were ejected from Mars due to asteroid impacts and eventually made their way to Earth. Some of these meteorites contain microscopic structures that resemble fossilized bacteria, though this remains a topic of debate. Panspermia suggests that microbial life could have survived the journey between planets, shielded within rocks. Experiments conducted on the International Space Station have demonstrated that certain hardy microorganisms, such as tardigrades and extremophiles, can survive the harsh conditions of space, lending credibility to the idea that life could have been transported between planets. The role of Martian chemistry. One of the strongest arguments for life originating on Mars rather than Earth comes from planetary chemistry. Studies suggest that early Mars had a more favorable chemical environment for the formation of RNA, one of the essential molecules for life. A key component of RNA formation requires specific oxidized minerals, such as boron and molybdenum, which were more abundant on early Mars than on Earth. Dr. Stephen Benner, a leading scientist in this field, has proposed that the conditions necessary for assembling complex organic molecules were more prevalent on Mars, making it a more likely birthplace for life. This idea is supported by the presence of these minerals in Martian meteorites, suggesting that the planet had the right ingredients for biochemistry long before Earth did. Why life may have migrated to Earth. If life did indeed begin on Mars, how did it make its way to Earth? The answer lies in planetary impacts. Mars has experienced numerous asteroid and comet collisions, some of which were powerful enough to blast surface material into space. Over time, some of these ejected rocks would have found their way to Earth, carrying any potential microbes with them. The journey from Mars to Earth could take thousands or even millions of years, but experiments have shown that microbes encased in rock could potentially survive the radiation, cold, and vacuum of space. Once these Martian meteorites reached Earth, they could have seeded our planet with the first life forms, kickstarting the process of evolution that led to all known life today. Implications for the search for extraterrestrial life. The idea that life originated on Mars has profound implications for astrobiology and our search for extraterrestrial life. If life did begin on Mars and then travel to Earth, it suggests that microbial life could be more common in the universe than previously thought. It would mean that life can start on one planet and spread to others, increasing the chances that life exists elsewhere in the cosmos. This hypothesis also makes the exploration of Mars even more crucial. If scientists can find definitive evidence of past or present life on Mars, it would not only prove that life existed beyond Earth, but also potentially confirm that we, as humans, are descendants of Martian organisms. Challenges and counterarguments. Despite the intriguing evidence supporting the idea that life may have begun on Mars, there are still several challenges and counterarguments. One major issue is the lack of direct evidence of life on Mars. While organic molecules in water have been found, no definitive biosignatures have been detected. Additionally, Earth itself had conditions suitable for life around the same time. Mars did, making it equally plausible that life originated here independently. Some scientists argue that while Mars may have had the right conditions for life, it is unnecessary to invoke the idea that it spread to Earth when life could have just as easily emerged locally. Conclusion: are we all Martians? The hypothesis that life originated on Mars and then traveled to Earth remains one of the most exciting and debated ideas in astrobiology. The evidence from Martian meteorites, early planetary chemistry, and space survival experiments all suggest that this is a plausible scenario. If future missions to Mars uncover definitive proof of past life, it could fundamentally reshape our understanding of our own origins. Whether or not we are truly Martians, the search for life beyond Earth continues to inspire scientists and explorers alike. The next few decades of Mars exploration may finally answer this age-old question, bringing us closer to understanding our place in the cosmos. What if everything you know about life's origins is wrong? What if, instead of Earth being the birthplace of life, it all started on Mars? Could it be possible that we are, in fact, descendants of ancient Martian microbes? Let us know your thoughts in the comments below.